So back to these things that we talked about in our that opening slide, heterogeneous mixtures versus homogeneous mixtures. So heterogeneous mixture, a mixture in which the components are not distributed uniformly. So the mixture contains distinct regions or different compositions. I referred to that as layers on that previous slide. Okay. And then, of course, we have a homogeneous mixture, a mixture in which the components are distributed uniformly throughout and have no visible boundaries or regions. So in chemistry, it can be often difficult to tell when you have a homogeneous mixture. For example, if you go get water from your tap, right, tap water, lovely. It might seem like it's just one pure substance, only water, but guaranteed there's some dissolved stuff in there. There's some metals, some ions, okay? And those aren't bad for you unless you live in Flint and there's too much lead. That totally sucks. We're going to talk about that. In Chem 110, I want to talk about that phenomenon actually. You wouldn't be able to really tell that there's stuff in there, okay? So telling when something is homogeneous can be kind of challenging. But when something's heterogeneous, you can usually see distinct layers. Sometimes you might even see what we call a precipitate. Precipitate, okay? Which would be like solid chunks at the bottom. So, let's suppose you've got a cup of dirty river water, right? And there's all like these chunks, like you're actually seeing some dirt and chunks in there. That's what we call a precipitate, and that is quite clearly heterogeneous. Okay. But now if all of those chunks end up dissolving and you don't see this distinct region or layers or precipitates, then it's become homogeneous. All right. Moving along. So this is the process by which we can separate heterogeneous or homogeneous mixtures. Okay, so filtration is typically best used for separating heterogeneous mixtures. And with filtration, there's a physical barrier that would keep, for example, like the solid chunks from remaining up here, but would allow the liquid to pass through there. Okay. There are also these very cool devices called separatory funnels that look like this. It's kind of got this bulb and a little opening where you can pour the liquid down that way. And there's a little valve here that allows you to either open or close it. And if you have a heterogeneous liquid mixture, so let's suppose you have oil and water. Oil and water will make two distinctive layers. So your oil will be on top because it's light, and your water will be on bottom because it's heavy. So there's these very cool devices called separatory funnels. I'll just write sep funnel. And you pour the liquid in with this closed, and they allow those layers to build up. And then now what you can do is open that, and one layer at a time will pour out. So that's a useful way of separating heterogeneous liquid mixtures. Separating heterogeneous solid liquid mixtures is best done through filtration. Okay, so distillation typically is used for homogeneous mixtures. And this is a separation technique in where the more volatile components of a mixture are vaporized and then condensed. So what that means is the stuff that can evaporate easier will be separated first. So you imagine here is your mixture. Okay, and this flask here. And there's a little Bunsen burner right there. It's hard to see it, but there it is. It's heating the mixture up. And in this mixture, there will be substances that have different boiling points, okay? And the thing with the lower boiling point will evaporate first and travel up this tube, and then it will condense because you typically have cold water circulating in and out of this thing. So this is literally called a still, and this is how you make booze. This is how you make alcohol. You separate the alcohol from the water, and then now the pure alcohol moves over to this side and thereby gets separated from the water. Okay. So most of these techniques you won't really get into until until you're physically in a lab, right? But like you won't learn distillation until you go on to take organic chemistry. And same with using these separatory funnels. But you'll get into filtration quite a bit if you are lucky enough to get to take a general chemistry lab in person. I hope that you do. But if not, we've got these really great videos that I think are also, or simulations. They're going to help you simulate these processes.